Hi everyone, welcome back. Today let's study about circles. You would have already studied about the basics of circles in the lower classes. In today's class, let's study about angle properties and cyclic properties of a circle. Before we start with these results, let's understand some of the basic terms that we use in this particular chapter. The first one is an arc. Then the next is a segment, central angle and inscribed angle. What do you mean by an arc? An arc is a part of a circumference of the circle. We know that this is the circumference of the circle and here O is the center of the circle. So any part of this circumference is known as an arc. Here we can say that this is an arc AB. And if you consider this arc, this is smaller than the semicircle. You know that the diameter divides a circle into two equal parts. Each part is a semicircle. And if the arc is smaller than the circumference of a semicircle, then it is known as a minor arc. And if the arc is bigger than the circumference of the semicircle, then it is known as a major arc. And here we know that MN is the diameter of the circle. We know that the line segment joining any two points on the circumference of the circle is called as a chord. Here XY is a chord. And if you consider this MN, even MN is also a chord and it is the diameter of the circle. And this MN, that is the diameter, is the biggest chord of this circle. Now, the next is the segment. What is a segment? The segment is the part of a circle bounded by a chord and an arc. If you consider this XY, the chord XY, the shaded portion here is the segment. And if you consider this, you can see this is the minor arc. Arc XY is the minor arc. Therefore, this particular segment is the minor segment. Now, if you consider the other portion, that is XAY, the entire arc, this is the major arc, the complete area, that is XAY along with the chord XY, this particular portion, that is the major segment since it has major arc and the chord. The part of the circle which is bounded between the chord as well as the arc is called as the segment. Here it includes the major part, therefore this is the major segment. Now if you consider the portion which is divided by this diameter, here MN is the biggest chord and the chord MN along with this arc is the semicircle because it includes half of the area of this circle. Therefore, this is called as a semicircle. The next is the central angle. If you consider a circle with center O, the angle subtended at the center by an arc is known as the central angle. This angle is subtended by this particular arc AB and it forms at the center O. Therefore, this angle AOB is called as the central angle. Angle AOB. This is the central angle. The next is the inscribed angle. There is only a slight difference. Again, the same way itself. The angle subtended at any point on the circumference of the circle by the given arc, that is called as the inscribed angle. So if you consider APB, angle APB is the inscribed angle. Angle APB is the inscribed angle. Inscribed angle is the angle at any point on the circumference. Angle formed at any point on the circumference by the given arc. That is what called as the inscribed angle. Now let's see the first result. The first result says that the angle subtends at its center. Here O is the center of the circle. The angle that an arc of a circle subtends at the center. At the center is double that which it subtends at any point on the circumference of the circle. That is the result. That means angle AOB is double of angle ACB. The angle that an arc of a circle subtends at the center is double that which subtends at any point on the circumference of the circle. This is what the result. In simple words, we can say that the central angle is double the inscribed angle. So we have already seen in the previous part that angle AOB is the central angle and angle ACB is the inscribed angle. As per the first result, we can say that the central angle is double the inscribed angle. So here angle AOB is the central angle and ACB is the inscribed angle. And if you consider any other inscribed angle with the same arc, if you consider this ADB is another inscribed angle. If you see this, you can see that this ADB is also formed by the same arc AB itself, and AOB is the central angle and this AOB is double that of ADB. Here ADB is the inscribed angle and AOB is the central angle. So as per the first result, we can say that central angle is double the inscribed angle and it should be subtended by the same arc. So this is the first result, and the second result says that the angle in the same segments are equal. If you consider a circle here and XY is an arc and here this straight line XY is the chord of this particular circle and O is the center of the circle. If you consider the segment XBY, that's a major segment here, XBY. We know that this is a major segment and the angles formed are XBY, and if you consider C as a point over here, XCY, or consider some more angles in the same segment, XEY. These are the different angles, and if you measure these angles, you can see that all these angles are equal, and we can say the result as the angle in the same segments are equal. Here the segment is XBY, or we can say XCY is also of the same segment. So the angles formed in the major segment, here you can see this is a major segment, all these angles are equal. In the same way, you can consider even the minor segment, and here also you can say that whatever the angles formed here, even these angles will be equal. So that's the second result. Angle in the same segments are equal. Angles in the same segment are equal. Angle formed in the same segment are equal. Now if you consider the third result says that angle in a semicircle is a right angle. The angle formed in a semicircle is a right angle. If you consider this circle, O is the center of the circle here, and if you consider any angle which is formed by this diameter, this is 90 degree. If you consider it anywhere on this semicircle, we can see that this is 90 degree. So the third result says that the angle formed in a semicircle is 90 degree. So the first result is that central angle is double the inscribed angle. And the second result is that the angle formed in the same segment are equal. And the third result is the angle in a semicircle is 90 degree. Now let's solve few sums using these results. Consider the first question. It is given that O is the center of the circle and angle AOB is 70 degree. Calculate angle OCA and OAC. These are the two angles that we have to find. Here it is given that angle AOB is 70 degree. So we can just write the data what is given. Given angle AOB is equal to 70 degree and here O is the center of the circle, therefore this is the central angle. Now if you consider angle AOB as well as angle ACB, we can say that this ACB is the inscribed angle and which is formed by the same arc AB itself. Look at that. Here this AB is the arc for the central angle as well as for the inscribed angle. Therefore, we can say that angle ACB is equal to half of angle AOB. The result what we can write here is the inscribed angle is half of the central angle. Our result was the central angle is double the inscribed angle. That is same as the inscribed angle is half of the central angle. Therefore, we will get the value of angle ACB as half of 70 and that is same as 35 degree. So, angle ACB is 35 degree. Angle ACB is equal to 35 degree. This implies angle ACO is equal to 35 degree. This is one and the same. That is angle ACB is same as angle ACO. Now if you consider the second part of the question, that is angle OAC. This was the first one. And if you consider the second part, that is angle OAC when you are finding. Here we found this angle ACB as 35 degree. So if you consider this angle, we can say that even this is 35 degree itself because the angle opposite to equal sides of a triangle are equal. If you consider the triangle COA, this CO as well as AO are equal because these are the radii of the circle. So this becomes an isosceles triangle and angle opposite to equal side of this triangle are equal. OCA is 35 degree, therefore CAO is also 35 degree itself. To find OAC, we can consider triangle OCA and triangle OCA is an isosceles triangle with OC is equal to OA. Therefore, angle OAC is equal to angle OCA. The reason we can write here as angle opposite to equal sides of a triangle are equal. Therefore, angle OAC is equal to 35 degree. That is what we have to find. So, by using this result, we can find value of angle OCA as 35 degree as well as angle OAC is also 35 degree. Now, this question is for you. Solve it and let me know the answer. That's all for today. We'll meet in the next class with a continuation of the same topic. Thank you.